Welcome back, friends. So I think we have stopped this definite integrals at understanding the problems of various areas related to sums and then certain properties of different integrals. I think that is a place where we stopped. Let us first continue from the properties of definite integrals. There are 7 properties, at the most 8 I remember, in the NCERT textbooks available for us. So let us discuss each of these properties and then try to understand these properties by solving a few sums. Today we will dedicate ourselves to list out all the properties of definite integrals and then go to a few sums. Then from there we will continue further. Okay, let us go to the whiteboard first. Yeah. So, what is our today's agenda or topics? Definite properties of definite integrals. Properties of definite integrals. Yeah. Let me check whether sufficient volume is there or not in our video. Yeah, it's available. So now, what is the first property? The first property is very simple. Integral a to b f of x dx is equal to integral a to b f of t dt. What does it mean? It means that the integral function can be changed to or transformed to any other variable called t in such a way that limits do not alter. This is the first property. What is the second property? Integral a to b f of x dx is equal to minus b to a f of x dx. What did we do here? We have interchanged the limits. Top limit, upper limit became the lower limit. Lower limit went to upper side. But we have to put a minus sign to achieve this. This is second property. Then let us see the third property. In the third property, we are having integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. This is another property which will be useful while solving some complex sums in trigonometric functions, like where sums we have done in integration by parts and all, like x sin x or x square sin x. Such a sums if you get, you have to use this type of transformations. The sum will become simpler. Then next one, integral a to 0 to a. This is a special kind of property which is derived from the property 3. 0 to a f of a minus x dx. This will be very important property which we'll be using in the sums. Next, fifth property, integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of a minus x. Please understand thoroughly. 0 to 2a f of x dx, you can split into sum of two integrals. First integral is 0 to a f of x dx. Second integral 0 to a f of a minus x. So 2a is now divided like 0 to a, 0 to a kind. We have divided into two limits. Sorry, two integral functions. So this is a very important property. Next one, integral 0 to 2a f of x dx is equal to 2 integral 0 to a f of x dx, 2 integral 0 to f of x dx if f of 2a minus x is equal to f of x, or this is equal to 0 if f of 2a minus x is equal to minus f of x. So this, while working out, we'll understand thoroughly. If there is a limit or integration, definite integral 0 to 2a f of x dx, this can be written as 2 integral 0 to a f of x dx if f of 2a minus x happens to be f of x, or if this becomes 0 if f of 2a minus x is equal to minus f x. This while proving this property, we'll just understand this. Next one, last property, minus a to a f of x dx is equal to 2 integral 0 to a f of x dx if f of x is even, or this value will become 0 if f of x is odd. So these are the 7 important properties in the definite integrals. So while proving first property, what is the first property for us? Proofs. Proof of properties of definite integrals. So let us prove now these whatever we learned. Out of this, first 3 are very easy. Other one little bit work is there, that's all. What is our first property? P1. This we call as P1 or P0, whatever you call. Textbook they have given P0 NCERT. We call like that only. Here, integral 0 to a to b f of x dx is equal to a to b f of t dt. Very simple. Let us say f of x is equal to x square, 1 to 2. Okay? Then put x is equal to t. Then limits. We have to change the limits also, no? And what will happen? If x is equal to 1, t is equal to 1, lower limit is 1. Then if x is equal to 2, t is equal to 2. So what happened now? Integral 1 to 2 f of x dx is equal to integral 1 to 2 t square dt. So dx will become dt here, which is nothing but integral f of t dt. So what happened now? Even though x became t here, limits did not change. That is the main property here. Next, what is our P2, P1? Second property. Integral a to b f of x dx is equal to minus sign b to a f of x dx. So here we will use the fundamental theorem of calculus. Fundamental theorem of calculus. This will we use. What we do here, you know that integral a to b f of x dx is equal to, let us say the integrated function is f of x. So here you write down a to b. So how do you apply the limits? F of b minus f of a. Take out minus common. It will become now f of a minus f of b. So this entire thing can be written as b to a or minus f of x integral b to a. This is equivalent to this. Any doubt is there? No, nothing. No. Simple. B to a f of b minus f of a minus n you put. This is f of a minus b. A is upper limit. So we can write like this. So if you want to change the limits, we have to put a minus sign. Okay. Next, another important thing is P2 or P3, this one, P1 is over, P0, P1 we have done. Next we have to do P2. This P2 property is very simple property but very interesting property. F of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. Okay. So what does it mean? That means we have got in between one point between a and b. So first we are integrating from a to c, then from c to b. This is called as the integration property of the second one. Integral a to b f of x dx can be written as a to c f of x dx plus c to b f of, doesn't matter, because within this boundaries a to b, you can choose any point c, integrate your functions between a and c and b, add them up, you'll get the total value which will be equivalent to straight away integration. Like f of a, f of b minus f of a can be written in terms of f of c minus f of a plus f of b minus, like that, f of c minus f of a plus f of b minus f of c. So this one, like this, first a to c plus b to c. This can be written like this. Okay, so now you can cancel f of c and f of c. You'll be getting fb minus fa back. Done. So this is also over, very important property. This is, it is equivalent to this in between interval. Even if you choose, finally you'll get the same answer. So next property, integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So this is very simple property. We will do like this. Put a plus b minus x is equal to t. Okay. Then minus dx is equal to dt. Then what about limits? Put x is equal to first lower limit. Put x is equal to a. Then what will happen? A plus b minus a is equal to t, cancel, so t is equal to b. Then put x is equal to b, and a plus b minus b, b and b cancel, so t is equal to a. So when you have put the x is equal to a, you got lower limit b. That means let us rewrite this sum. F of x dx is equal to integral. How did we change the sum now? This x value we should write here. F of a plus b minus t, first you should write. Then dt. dt actually minus dt. This is dx value. In the place of dx, we should write minus dt. So minus, I brought it out. Limits became now, lower limit became b, upper limit became a. So now you know from the previous property, when a minus sign is coming, limits can interchange themselves. So a to b we can write back. A plus b in the place of t, you can write x here, so it become dx. So this entire sum, this is by p by property. Now need to just remember this. In the place of t, you can write down x, first property we have done. So therefore a to b, f of a plus b minus x dx completed. Next, hope you understood this. Just take this substitution. differentiate both sides and you get dx dt. Then limits you apply, get the lower and upper limits, take the sum, then substitute here properly. Next property. What is the next property? Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Like previous property here also, you take the substitution, put a minus x is equal to t. Then what will happen? Minus dx is equal to dt. Then limits. Limits we have to change. So when x is equal to 0, a minus 0 is equal to t or t is equal to a. When x is equal to a minus a is equal to t, okay, 0 is equal to t. That means lower limit 0, when we have put, we got a. So our sum first write down as it is. This is the sum given to us. So what you write, when 0 applied, this became a. When a you applied 0, it became f of x place, we can write a minus t, the minus sign. So again, change the limits with sign. Because minus sign is there, you can reverse the limits. This will become 0 and the top one becomes a, f of a minus x dx. So we have proved this. Next property, integral 0 to 2a f of x dx is equal to integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of a minus x dx. This is the property what we are supposed to prove now. Correct or not? Yeah. Integral f of 0 to 2a. Yes, 0 to 2a. This is 2a. Okay, na? 0 to a f of x dx plus integral 0 to 2a f. Yeah. Correct. Yeah. Now let us consider. We know that integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral a to 2a f of x dx. This we know because we are, instead of directly going to 0 to 2a, you can stop in between at one point called a. Again from a to 2a you can go like this. This is 2a, this is a, this is 0. 0 to a to 2a. That is what we have written here. So now consider second. Consider integral 0 to 2a f of x dx. Let us consider this one. Then put 2a minus x is equal to t. Then your differentiation both sides will become dt. Then limits. In the limits, x is equal to 0. If you put 2a minus 0 is equal to t or t is equal to 2a. If you put x is equal to 2a, t is equal to 0. So our sum now became integral a to 2a, the second integral, f of x dx is equal to, okay, a to 2a, this second integral. Consider second integral. We have tried clearly here. Consider second integral a to 2a f of x dx. This integral now we are writing here a to 2a f of x dx is equal to integral. What did we do now? F of in the place of x, first you write down transformation. Yeah, x is equal to 2a minus t dt with a minus sign outside, and here in the place of a, when you put a here, a x is equal to limit here a, no? Yeah, sorry, here small error came. See, limits are a and 2a. When we are putting x is equal to a, 2a minus a will become a. So this will become now t is equal to a. When you put x is equal to 2a, then 2a minus 2a will become 0. So our limits became, when you put the a value lower limit, x is equal to here, yeah, x is equal to a, when you put this will become, yeah, like this. So upper limit became 0. See, x is equal to 2a when you put, this is upper limit. This is now lower limit. Is it required to write? I think unnecessary confusion, simply I'll leave it like this. So a is equal to here a. When you put 2a, it became 0. So upper limit, observe here. If you observe here, you will come to know. Then let us write back this as it is again, as it is. Integral 0 to 2a f of x dx, sorry, a to 2a. This became now minus sign integral a to 0 f of 2a minus t. This is what we are having. So this we can write as integral 0 to a f of 2a minus t dt. So this also can be written as 0 to a f of 2a minus x dx. Now, therefore, our total integral 0 to 2a f of x dx. So from first equation, what is our first equation? This one. From first equation, this is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. Understood, no? Little bit, 2-3 times if you do, you'll understand very clearly. 0 to a f of x dx, 0 to 2a f of 2a minus. This is the proof what we are having here. So this one we have considered like this. Yeah, completed, no? Same thing we have done. 0 to 2a P7. This is P6, I think. To integral 0 to 2a. Yeah. 0 to a, 0 to a, remember. Let us check once again this property. What we have written first time. First property, let's see, let us see here. To integral f of 2a minus x. Yeah. P4 is over. Then P5, 0 to 2a, f of 2a minus x dx. 0 to a, 0 to a, this is I remember. Let me just check once this property what we wrote now. Is it correctly written or not? That's just confirmation only. F of 2a minus x, lastly we are getting. So 0 to a. So 2 integral 0 to a. Yeah, this is f of a only. To a. Correct only. Both should be limits A only. Correct. So this is correct only. So carefully do and repeatedly we have to do the sums. Otherwise we will forget the fundamental. The next one is now P7. So integral 0 to 2a f of x dx is equal to 2 integral 0 to a f of x dx if f of 2a minus x is equal to f of x, or is equal to 0 if f of 2a minus x is equal to minus f of x. So previously from P6, what we did, integral 0 to 2a f of x dx we have written as 0 to a f of x dx plus integral 0 to a f of 2a minus x. Correct? Now, if f of 2a minus x is equal to f of x, then what will happen? 0 to a f of x dx, 0 to a f of x dx. This will become 2 integral 0 to a f of x dx. Now, if f of 2a minus x is minus fx, then integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of minus x. So directly you can write minus x. This is minus sign, okay? So cancel out both, we'll get 0. So this is one result, this is another result. That means the nature of this function is deciding the overall value. P6 decides that. Let us go to the last property, which is very, very important. Minus a to a f of x dx is equal to, correct, 2 integral 0 to a f of x dx if f of x is even, or 0 if f of x is odd, right? So this property, very, very important property, we'll derive this. So now, how did we do previously? We know that this can be written as minus a to 0 f of x dx plus integral 0 to a f of x dx. Okay. This I have split now like this. Okay. Yeah, once P7 I am proving. So let us see. Consider first integral, that is minus a to 0 f of x dx. So in this integral, put minus x is equal to t. Then what will happen? Minus dx is equal to dt. Limits. So x is equal to minus a. X is equal to a, no? Then that will what happens? Your lower limit is minus a, correct only. Then t will become a. When x is equal to 0, t is equal to 0. So upper limit is 0, lower limit is a. So what will happen now? Integral a to 0, you will be getting f of minus t dt. So this can be written as, if we change the limits, a to 0, f of minus x dx. So that means our entire sum, integral 0 to a f of x dx plus integral 0 to a f of minus x dx. This is all what? After this sum, therefore, previous page just observe. Integral minus a to a f of x dx. Implies this one. Integral 0 to a f of x dx plus integral 0 to a f of minus x dx. So if f of minus x is equal to f of x, that is even, then integral minus a to a f of x dx will become 0 to a f of x dx is equal to 2 integral 0 to a f of x dx. If f of minus x is equal to minus f of x, then integral minus a to a f of x dx is equal to integral 0 to a f of x dx as it is. In the place of f of minus x, we have to write so this and this get cancelled to 0. So friends, these are all the properties of different integrals that are relevant in doing the sums. Don't worry, again we'll repeat, try to discuss again and again. 7 properties are there, last 3 you try to recollect, remember. 2-3 times if you work out, it will be easy. Any doubts are there, you can call me and ask me or leave in the columns. And we'll do the exercise sums in the next class onwards by applying these theorems. These theorems only examination point of view. Last 2-3 theorems they may ask for 1 or 2 marks. Please remember them, but their application is most important. Thank you. Let us meet in the next class.